Hello everybody and welcome back. So in this next lesson we're just going to continue from the previous lesson, just splitting it into two parts. So now we're going to be doing the who.node module, but the more intermediate and advanced functions. Right, enjoy. Right, so those are some of the most basic functions, but let's move on to some stuff that's a little bit more a little bit more complicated, or sometimes I find these are a little bit confusing. So it may not be a complicated function in and of itself, but the way that it is meant to be worked with is a little counterintuitive. And so I've kind of grouped these together in a little bit more of the kind of intermediate functions that you might come across. Right. So one of them is set input, right? So let's say we have this over here, right? And we want to set test as an input to this subnet, right? So we essentially want to plug this in, and we want to maybe plug it in there on the third one. Okay, but we want to do this through code, right? So I've still got a reference in to this node, but let's grab a reference to our subnet as well. So let's just call this one S. So S equals subnet and N equals the node. Now, I want to set the input of the subnet. So even though when we're plugging it in, you can plug it in this way or the other way, like physically you can do this. But because this node is operating on the this function is operating on the node, I want to run on this node, I want to set its inputs, okay? So I'm basically going to run the function on S. S is going to be self, right? So we say S dot and then set input, right? So I just want to point out that again, that we're not, even though we're plugging N in, we don't go N dot set outputs. Instead we say S dot set input, right? That's the right way to do it. So S dot set input, then the arguments that it takes is, okay, self, which we've given it, S dot, then input index, so in other words, which one of these should we go in, and remember it's an index, so 0, 1, 2, so we give it number 2, and then, okay, see that's disappeared, so let's just use this so you guys can follow along. So input index, then the item to become input. Right? Now that, let's read in the help file here. It very specifically says, if it's none, this is actually something really good to know. If none, then this method disconnects everything from the input connector. Okay? And then, so it'll actually remove anything plugged in. And if a who.node or a who subnet indirect input, so these are two different classes, right? So if the input that we're giving it, the object that we feed it here as the second argument, is one of these two types, then it's going to connect it, right? It obviously can't connect something else. If we give it, I don't know, a parameter, you can't connect a parameter to a node, so it's going to error out and say, whoops, I can't do that. But if we can either feed it a none to unplug from that node, or we can give it a node or a subnet input, right? Okay, so this is where we would give it our N, because we already have a reference to it, so we might as well use our variable as a way to call the reference to this instance of the node. Okay, so we say in input 2, plug N in, and then the third argument is output index. Okay, in other words, the output of the node. Now here we only have one. And it assumes that a lot of nodes have one. That's why this actually even has a default. So output index equals 0. It's going to assume 0. So we can even leave this one out and it'll just assume that it's 0. But some nodes have 2 outputs or 4 outputs or whatever. And so if you want to be specific about which output it's being plugged into, so if we're saying 2 here, which is this, but where in here is it coming out of? Okay. And in this case, it's just 0. So we can either give it a 0 or we can leave it out because that was a default. Okay. And now when we do that, it plugs into number 2. It plugs that. All right. And again, let's try it with a none. So remember, we still reference input number 2, which is 0, 1, 2, so it's the third one, right? But instead of n, if we give it none as a type, so remember that is an actual Python data type, is none, then it's going to unplug that. All right, so that's quite useful. Now, this function, this next function we're going to talk about, is something that seems really easy, but it actually trips a lot of people up, okay? And that is setting color. Okay, sorry, I keep forgetting we've got n stored, right? So what we want to do is set the color of this node, okay? So n dot, now if we call color, okay, and again, for any of you like me in the UK or whatever, we're used to spelling it with a U, it's not. It is spelled the American way, so color like that. Okay. So that is going to return a who.color function over here, right? And it's important, very good to know that it needs this who.color input, okay? Because we're going to need to now actually create an instance of that who.color, and it's also great because the who.color class has its own sub functions that let us alter this color. So for example, if you don't want to store RGB values, well, even though it's stored this way, you want to alter the saturation of a color, you can actually run a function, convert it to HSV, alter the saturation, and then convert it back to RGB, and you've been able to essentially, you know, alter the saturation, and it will calculate what the RGB value of that is. So sub functions of this, very, very cool. Okay, so you guys can look into that node. It's just got a few functions, the class. So you can just search in here who.color. All right. And in fact, we'll do it now. So we can ask for the color. So we go n.color, but we can also say n.set color, right? But here, what we need to do is give it an actual who.color. Now, I haven't tested this, but I believe that it will not work if I just give it a tuple. Okay, this shouldn't work. Yes, see, it gives an error, and this is where most people think you can, and I can't tell you how many times I've gotten tripped up by this, because you don't use the function for a little while, and then when you do use it, you go, oh, I just want to set the color to RGB, so 100, so this should make it red. And then it gives this error. And it's because what it wants specifically is not just a tuple. I don't just assume that you're giving it RGB values. It wants an instance of a who.color type. Okay. So let's actually pull up that class and have a look at it quickly. So let's create another tab here, and I'm just going to type who.color. Whoops. Okay, there we are. So it's a class, okay, and it has a list of functions, okay, not a ton, but a few functions. And what you'll see here, the difference between this class and the who.node class is the fact that it actually gives us an init function. Now remember when we created our human class, the magic methods, which have the double underscore, were the ones inside of it that were essentially determining how the node functions when we do normal Pythonic kind of functions like adding them together, or init, like creating one. Okay. So this gives us an init function, but the who.node actually doesn't have one here. And that's because it cannot be just created. Remember when we tried to just create one in here, it said, well, I can't do that. There is no constructor for it. Well, here is our constructor. That means that we can create this without having to refer to one. We can just instantiate it, okay? And what it takes as an argument is RGB values, but as a tuple, okay? You see these are a tuple, okay? So it's not 3 different values, it's one tuple of 3 values. And it also has a default of 000. So actually we can just create a black color by just going, so I'm just gonna call it my col. I'm just gonna store it in a variable and just say equals who dot, and then remember capital C for color because it's a class that we're referring to, but with the round brackets this means that I am calling the constructor, so this init function. If I just give it like that, then my col, the variable, will be essentially an alias of the who.color. If I use the round brackets, it actually calls this constructor and creates So now if I say mycol, you'll see it's an instance of who.color with R, G, and B values equal to 0, because of this is the default. Now instead of doing that, if I say mycol equals who.color and then I give it 1, 0, 0, okay, now I say mycol, okay, and then, oh wow, actually sorry, I didn't realize that if we feed it 3 values in this, it actually accepts it instead of needing to be a tuple specifically. So that's quite nice. You see, sometimes these functions are a little bit more flexible, and others they're very picky about it. So that's why I always say rather err on the side of being more cautious, because I think it won't complain if we give it a tuple, but sometimes they are pedantic and other times it isn't. So rather just be safe than sorry. So either way, we now have mycol and it equals our value of 1. So this should be red. Okay. So now when we say n.setColor and then we feed it mycol, that is now going to work. And you'll see that it has changed our node to be red. Okay. Now obviously you can do that in one line. You don't have to actually create a variable. If we know we're never going to use that variable again, then you really are welcome to do it in one line. So we can just say n.setColor and then we say who.color, and then maybe let's go 0, 1, 0. Okay, and now we set it to be green. Okay, so you can do it in one line, and I often do, but it's if you're ever going to use this again somewhere else, you don't want to have to create it again. That's kind of the coding like golden rule, is to never repeat code. So if you're wanting to repeat this and use this later, then it's better to store it in a variable and then refer to the variable twice or 3 times or whatever. Okay, so there we are creating color, and you see that one trips people up, so I just wanted to show you that very specifically. Now something else that we often do with nodes, and a lot of the time it's with SOPs more specifically than even these geonodes, is setting display flags and render flags, or disabling them, basically clicking these buttons. Okay. And I mean, in SOP context, it's so important where your render flag and your display flag are. So which node are they on? Okay, so there's a box. We've got maybe another grid, and then I'm copying boxes onto. Copy to points, and I've got some of these boxes copied onto my grid. Okay, so you know some nodes set up here. Now it's very important where the display flag and the render flag is, and we can even split them. So we're moving our display flag, our render flag. We can set the template here, disable the grid, freeze this. So there's a lot of stuff happening here, and this is and there's even a few hidden ones which I'll actually show you just now. So we want to be able to manipulate that type of stuff as well. And then on the top here, you've got fewer options, but still it's important to know whether the node is displayed or not and whether it's selectable or not. So what we're going to do is there is an old method, and this is something I really want to show you, because this will be deprecated at some point. So you need to not get into the old method. Okay, so I'm going to show you where it is, and it still exists, but please try to avoid using it, right? So the set display descriptive name flag. Oh no, wait, sorry, that's not that one. Anyway, in fact, you know what? I think it doesn't even appear in this list anymore. That's why. Like, it's basically set display flag and set render flag were the functions. Now, I think they still do exist. Let's just check. Dot set display flag false. Okay, so you see it did work, but it actually doesn't even exist in this list anymore, and that's because they're trying to discourage people from using it. And I would discourage you from using it too, because if you go and build code now with this in, it's going to reach a point where you're going to have to, your code is going to start breaking because you're calling a function that has actually been removed from Houdini. Okay. They often, when they're going to remove a function or change a function to something else, they will mark it as being deprecated. And they're essentially giving you many versions to change over and say, okay, this function still exists, but we're going to get rid of it. And then they warn you the next time, we're going to get rid of this, but eventually they will. So please don't use this. Okay. The reason why they've gone away from this is because this was just having too many totally separate functions. So there's set display flag, set render flag, but then what about set disable, set lock, set template, or selectable template? There's just too many. So they decided to consolidate it into one function that has a subclass of the flag type that you're referring to. And so this function is the, well, it's called the generic, under flags, is generic flag set and set generic flag. These are the two functions. The sort of calling, like asking, is it, like when we said what's the name, or we said set the name. Now this one's a little bit confusing. I'm not sure why it's named this way, because we're saying is generic flag set. It sounds like you're asking whether it is set or not, but I mean, you know, surely you want to know what it's set to, what the value is. So I don't know why they named it this way. But anyway, that's why I thought I'll point out that it is named a little bit weirdly. But these functions are very important because they allow us to change all of these different types of flags. Okay, so this one asks what the value currently is. This one tells goes and actually sets it. But the argument that it's asking for is a flag. And what the flag is it must be an instance of who.nodeFlag, and then so if we follow this, now I'm going to show you in the help file, when you see this, you can actually middle click on that and come and look at what this is. Now this is a sub module, okay, which is why it doesn't have a capital letter over here. It's not a class, right? It's its own module, okay, and it has a list of flags, right? And you see how many there are, because we're even talking about, I mean, there are nodes in, like, you know, chops and things, and, you know, there's so many different ones, including the display comment, which is a little bit hidden, which I'll be showing you just now. So there are all these different types of flags, and so they've consolidated it into a module. And now here what we do is we just choose one of those types, and then we can set the value of it with one function. Right, so let's do that. On our n, let's say n dot, and then let's start by asking. Let's just query. So we'll say is generic flag set. Now it says what flag? So we need to tell it. Now how we refer to that is, we remember it's a who.node flag module. So to call a module, we say who dot, then node flag. Okay, so you'll see it'll appear there. And now we do not call this module. We're not running the module. We're not instantiating or constructing it. Okay, we're just referring to something inside of the module. So we just say dot. The same way inside of the Houdini module is the node flag module. Well, inside of the node flag module is something. Okay, and these are just values in here, right? These are like properties. Okay. So we just say there dot, and then we can give it whichever one of these types we want to refer to. So in this case, let's just use the display one. Okay. Now you'll notice that they all have a capital letter here. Okay. So just make sure you type it correctly like that. And in fact, you'll see when we do here, click dot, it actually has a list as well. A little bit temperamental. Sometimes it doesn't pop up, but either way you can check it here. But then display is in the list. So we say display. And again, we're not calling this. This is not a function. It's just a value, right? So we just refer to it like that. And now it's going to say true. Now, if this was set to not display, that exact same thing would return false. Okay, so that's how we ask for it. But how do we set it? So let's do that on our node. So in fact, let's go do it on the inside over here. So let's maybe go and put our render flag on the box, for example. So we can now refer to our box and then say dot, and then the function is set generic flag. Is that the whole function name? Yes, set generic flag, yes. And then we give it the flag type, which is who dot node flag dot render. But we also need to give it a value. Now that value can be 0 or 1, or it can be true or false. You can use the Boolean, and in fact you'll see when it returns it always returns true or false, the actual Boolean value. But you can always use zeros and ones if you want to. Okay, and you see there it moved our render flag to the box. Okay, same thing we can do, but just with the grid. So we could actually run the same function, but just change this reference to grid 1, and now it's moved our render flag. Okay, and the exact same thing for making comments. Now that kind of leads me a little bit of a segue into the next bit, which is talking about comments. So what are comments, right? So have you ever seen these where on the node, if you click on here, open up, you can write a comment, remember to buy milk. Okay, obviously you don't really need the comment to remind you of that, but you want to remember something, whatever, so this node, you want to leave some notes on it, you attach a comment to it. Okay, now what I did here, you see what I did as a user was I typed it in this string field, and I also had to enable it to say show me this comment. Otherwise the comment is on, but it's hidden. Okay, it's got a little display saying there is a comment, but I'm not actually displaying the comment itself. So that's something else we're going to do now, is refer to comments. So now we can say node, so in fact our comments on here on our subnet, so I'm just going to drag that in. Say subnet dot and then comment. Now that just lets us refer to what the comment actually is, and it's going to return a string. So that's pretty simple. Okay, and if we do it on our n, you'll see that it just returns an empty string. Okay, but what we can do is we can alter this comment. Now there are two ways of doing this. One is just quite obvious, and I'm sure you can guess it, is set comment. So we can set this comment, and it's obviously once a string, so then we just say remember to do that thing. Okay, nice and specific. Right, and then you see it changes the comment. But something else we can do, which often comes up because the comment's already there. Now it would be quite a pain to have to refer to whatever the comment is and feed that back into here just because you want to add to something at the end. Like maybe you want to go, you want to type, oh, and also that other thing. Okay, now we don't want to have to do that. So what we can do is just append to the comment that already exists. Okay, so we do this, but instead of saying set comment, we just say, oops, sorry, let's type it correctly, append comment. Right, now this is going to keep the comment that was already there, but add to it. Now, because of that, you may want to actually start with a space if you're wanting it to actually have a space at the end there. Well, in this case, we want to start with a comma, and then we go, oh, and also that other thing. Okay, and then when we do that, it just appends it to the end of this comment, so you can keep attaching notes to it. Okay. Now, this will not display automatically though. Like, what if we on our n we just say dot set comment test comment. Okay, now test now has a comment on it, but we can't see it. We want to do everything in Python because a lot of the time this is going to be run in one big script. We're going to create a node, move it, set its color, set its shape, write a comment, make sure the comment is displayed, switch off its display flag, switch on its selectability. We want to do a whole bunch of things in one thing. We don't want the user to have to go and remember to display the comment. And this is one of those kind of hidden flags. These are, quite easily accessible buttons, but actually this here is one of the flags. You'll notice it in our list here, display comment. Okay, now this tripped me up for a while, and that's why I want to show it to you so that I can save you some time so you don't have to do the same thing. In here, you'll find that there's a whole bunch of functions to do with comments, all the functions that we were just talking about, but nowhere does it have the option of choosing whether or not to display the comment. And it took me a long time to eventually find that it's hidden inside of this. So we can now go n.set generic flag who dot node flag dot and then display comment oh, and then we need to set it to be true. And now it displays. Okay. So that's quite a tricky one. All right, now onto something really juicy, which is creating nodes, because obviously we're going to want to create nodes. It's something that happens very, very often. Right. Now, when it comes to creating nodes, what's important to know is that we need to know what the node type is. So let's start with that function, is asking the node what type it is, because all of these nodes, even nodes that are not HDAs, they have a type, right? Nodes that are not HDAs but that are standard Houdini nodes kind of operate similar to an HDA. It's just an HDA that we cannot alter. You know, we can't open it up and make changes or whatever, but really it still operates the same way. And every node has a type, okay, a definition. So if we point to our n, say n dot type is a function, okay, and this function returns what type this node is, okay, but it returns it as an object, okay. Whereas under that we can say, so essentially on this type, okay, we can ask what the name of this type is. In other words, it's saying return this as a string instead of kind of a complex object, right? Because on this type, let me just store it as a variable. My type equals n dot type. Okay, and now when we say my type dot, you'll see it has a whole lot of functions that we can apply to that node type, right? But one of them is, we'll find it in the list, name. So name basically says, tell me the type, but in string. Okay, and we'll use those two quite often. Now also, just before we move on, I just want to point out why I did this, why I stored it in a variable. If you're ever wanting that thing to pop up where it kind of shows you the options, you know, when you say n dot and then it's got this list of functions, it very rarely, if ever, does it when you are in a subtype. So if we go n dot type and call the function and then we go dot, because it hasn't run this function yet, it doesn't really know what is going to be returned from this, and so when we click dot, it doesn't know what list of functions to pop up. But if we go and store n dot type in the variable, now it has already calculated it, it knows what type it is. So now when I call my type dot, it appears with a list of functions. Okay, so I just want you to know why I did that. Okay, so we now know what type this is. Okay, it's a geo node. Okay, there is a type object, but it just has this name. So type.name will give you that. Okay. Now, if we middle click on a node, you'll actually see that in this description, it tells you in brackets what the type of the name of the node is. So you don't have to always do node.type.name. You can actually middle click and see what it is. Now, please be careful. Do not assume you know what type it is. This is a geometry node, but the type is geo, all lowercase 3 letters. Okay. You have to be very specific about what type this is. Okay. Now, geo to geometry, that's quite easy, but there are some nodes that are quite complicated, right? I mean, for example, like wrangles are not, even though they appear here, there's an attribute wrangle, like a point wrangle, a prim wrangle, there's a whole bunch of different ones. But if we middle click, you'll see that they're all called attribute wrangle, okay? So we drop down a primitive wrangle, middle click, it's still an attribute wrangle. And it's not even attribute, it's attrib wrangle, one word. So you do need to be very specific about the type. Okay. So now armed with that information, we can now create a node. So we want to go right now. So this is the next important part of this, which is why, see, creating nodes can be a little bit complicated because we need to be very specific about how we do it. We need to know the type, yes, but we also need to know how to call this function. Now, create node is not a function of the Houdini module. Okay, there is no who.create node. Okay, you start typing it and there is nothing. So it is not a global function of the module. It is a class function. So it's a method. And that means that I need a node to call it on. But that's quite strange, you might think, because, well, what if I've got an empty scene? And so how do I create a node if I have no nodes? Well, remember, obj is a node, and you can never get rid of that node, so you will always have that, right? So if you're wanting to create a node at the parent, it's like right in the root of obj, then you use obj, a node reference, a node type class reference to obj as the self object that you call the create node on. Okay, so let's start with that, the most generic way, which is creating a node just in the root. So we can store who.node reference to obj as a variable if we want to refer to it many times. But in this case, I'm going to actually just call it directly in one line, because why not? You know, we'll just say who.node obj, and inside of this obj node, we say dot create node. Okay, and this is a method, so it will be lowercase, but then in Houdini specifically, they've gone and put it with a capital letter at every word. Okay, so create node spelled like that. Right. And now what this takes is a node type. Okay. If we want to see what this is doing, let's jump inside of here and say create node. Okay. Now you're going to see this takes a lot of arguments. Okay. But most of them, all but one, are actually defaults. So it has to know what type we want to create, because obviously, I mean, that's a very obvious question. Create a node. Okay, what node? You know, like what type? So it needs to know that. But other than that, the node name, we can give it a name, or if we say none, then it will calculate a name for you. So it'll get the name from the type, but it'll append a digit to it as well. Okay, the same way when you drop a normal geo node in your scene, it calls it geo1. Well, that's what none is doing. But if we want to, we can give it a specific name. Then run init scripts. So run the initial scripts of that node. Because some nodes, when you drop them down, they do stuff. In fact, we're going to be doing that later on, is creating on-created scripts, script callbacks. So as you drop the node, it does several things. And a lot of the time it's innocuous. You don't even know that it's happened, but it's gone and set certain things for you. Now, by default, this is true, because any node you create, obviously you want to just run the scripts that go with that. But there may be some small cases where you know you want to create a node, but you don't want the initial scripts to run. You just want to create it in its raw form. And so you can change that to false. Load contents, that is true by default, but if it's false, it will then not load the actual contents. So then the subnets, if it's a subnet, will be empty, right? And then exact type name. So you can read here, if true, then the name will be exactly as specified, right? Otherwise, it matches the node type name. So it's basically, okay, when we get to HDAs, we're gonna talk about namespaces and stuff like that. But it's essentially saying, oh, should it name it using the actual namespace, or should it just call it the HDA? Okay, so in other words, the name of the type versus the actual version name, or you can put a namespace in front of the actual node name as well. Later on, we're going to talk about this in much more detail, so you'll understand it more then. And by default, that's false. Now also note that this returns a who.node. So it actually returns a reference to the newly created node, right? Which is very useful for us, because once we've created the node, we often want to change things, maybe change its name, change its color, change other things. I mean, we can set its name here if we want to, but we can't set its color. So maybe we want to change its color, we need a reference to it. Now the worst thing would be having to create a node and then go take the path. I can calculate based on the name where it should be in order to run the who.node function to find the node, and then it's just a pain. Whereas if we run this, and because it returns a who.node, if we just store this in a variable, not only is it going to create a node, but actually that node itself will be stored in that variable. Okay, So that's what we're going to do. So we say create node, and then we feed it a node type name. But you see, note that it says node type name, not node type. So remember here where we called node type, it gave that. That's the type. That's the type name. So the string is what it's asking for. Okay. So geo. Okay. And if we want to store this in a variable, then we can. So we'll just say we'll call it new node. Okay. Now when I hit enter, it creates a node, geo1, because we didn't give it any name, so it just knows it's geo1. But if I type new node, we already have a reference to that. So I can say new node dot set color who dot color 001, and now it's a blue node. Okay, so that's how we do that. Obviously you can go and fill in if you want a name, or you want to have the initial scripts not run or whatever, then you can call those keyword arguments. Okay. Oh, and it gives you an example at the bottom here. So this is also good. It's a good way to, if you've forgotten what we've learned here, at least it'll show you how to create nodes. Right. Now you can obviously create sub nodes as well. So like inside of this node, this new node, maybe we want to create something. So actually we already have a reference to it, which is new node. Yeah, new node dot create node. So now this will be creating a new child inside of that, and maybe we want to create an attribrangle. Okay, so then we go and do that, and it returns a reference to that node. Remember, because we didn't store it in a variable, so it's going to print it. If we go inside here, you'll see that there's now an attribute wrangle inside of there. Okay. All right, and then there's one more thing that we're going to talk about, is some advanced functions that we're going to be running on a node, right? Now, this section, again, I'm going to warn anybody who is maybe very new to it. I don't want to confuse you by giving you too advanced stuff, but I also don't want to skip the really advanced stuff, because then you'll never know it unless you learn it from some other source. So this course, I ideally would like you guys to run through the course several times on your own, especially if you're a beginner, because you'd learn the syntax from module 1, then maybe practice a little bit, then go back and relearn the syntax to make sure it's stuck. And then once you get to these bits where we're talking about functions, sure, I'm going to go across basic functions, but I'm also going to talk about some advanced ones. So if you're very new right now, you can just even skip this section or listen, but don't worry or panic if you're not following, because this gets very advanced. But later on, once you really have grasped Python and Houdini, then these sections are going to be full of valuable information that will allow you to kind of learn again. And learning really is like, it goes in layers. You really need to understand the basics before you can build the intermediate and then the advanced on top of that. Okay? But I want to give you all this information, because if I don't give it to you now, then once you've got the basics, well, then you have to take another course to learn the intermediate and advanced stuff. So I'm going to teach this bit, but if you're confused, do not worry at all. Okay, this is meant to be more advanced. Okay, and for those of you who are more advanced, I hope this is valuable to you, because this is something that took me a while to understand, but once you do, is really, really useful. Okay. So what we're going to be talking about is user data. Now, Houdini stores two different dictionaries of data on nodes, but specifically on the nodes themselves. It stores user data, okay, in this dictionary. And obviously with a dictionary, as seen by JSON files or whatever, we can essentially store any information, because we've got a key and then we've got this value, and we can store anything in that value, right? So it's essentially a way of just building a database of this data on a node. And there are two different types. There's user data, and then there's cached user data. Now, the only difference really is that cached user data is temporary. It basically exists now, but if you had to save your scene, close it, and reopen it, that data will be lost. It is only for temporary things. So when you're running a script, maybe you want to check all the nodes in your scene. So you check test. Once you've checked it, you could even write out a little report of what you found on that node. You know, for example, what color it is, or does it have a comment or whatever, and you gather some data and store it in a dictionary on the cached user data, so that when you keep looping through the scene or loop through it again later, if test has been checked already, then you can make the script run faster, because the first thing it does is it asks the cached user data, have I already checked this node? And there's already some data on there saying, yes, I've been checked. So then it'll skip this node and keep checking the new nodes, and so on. Okay, so the cached user data is just temporary, and you cannot rely on it to still be there when you close and reopen your scene. But user data, however, does actually follow nodes, and it is saved in your HIP file. Okay, so obviously be careful if you create a very complex dictionary. It is going to increase the file size of your HIP file, but you know, it would have to be a lot of data for it to really be significant, but it does. Okay, so it saves it with your HIP file, but it is saved on the nodes themselves. Please be aware of this. It's almost like these comments. Imagine if this comment, instead of just some normal string, was an actual dictionary full of, you know, a key and value pairings and stuff, and you could actually use this data to store multiple things. Okay, it's kind of like that. So there's a few functions that we can do with this. So we refer to our node, and then we say user data. Okay, so we can call user data and then just call an actual key to get value out of it. Now, at the moment, we don't have any value stored, so this will not work. So let's first store some values. But before we even do that, I'm going to show you that we can check the fact that we have an empty dictionary with the function user data dict. Okay, so user data dictionary. This is calling the entire dictionary. Okay, so when we do that, it's going to return the dictionary, which at the moment is empty. And that's exactly as we would expect it to be. But Houdini itself actually stores some data in user data sometimes for you. And because it's stored in dictionary format, it is safe to say that it won't overwrite your data that you've stored custom, like with a comment where it overwrites the whole comment with its own comment. But it is something you need to be careful of, because if you use the same key that they would use, then you will override it, or their data will override yours. So you do need to be careful what you choose as a key. And I want to show you an example of something that is stored in this user data dictionary, and that is the shape of the node. So you know these node shapes? So we can go make some really funky looking node shape. Now it took me really long when they brought out these node shapes, okay? And I know some people hate them, but I like them. I think it's fun. So yeah, sure, you want to use colors to differentiate with different nodes, but you also want to create these shapes to say, okay, well, this node is my explosion setup, and this is something else, whatever, you know? Like, I love how explicit they had to be with the light. They literally make it a light bulb. I mean, it's really cheesy in like a really fun way. Anyway, so these node shapes, it took me so long, because you assume that with this new function, okay, we've got node shapes, that we can go n.node shape. Maybe it's just called shape. And it took me ages. I was thinking, how do you actually change this? It's clearly stored on these nodes. It can clearly be changed, but I was used to the fact that Python could let you do anything that a user can do. And then eventually I found it. It's stored in the user data dictionary, right? So now that we've given it a shape other than default, if we run the same function, you'll see that our dictionary actually has a value called node shape. And then, that's the key, and the value is a string called burst, right? And all of these will have their own string associated with them, right? And I wonder if there's a way that you can see the list of them. Well, I'm sure in the help file there is a list. Otherwise, you can just figure out what the shape name is by doing it once. So we can just run that function again. This is called cloud. Okay, so I know that that's the one I'm looking for. And then you go and build that into your code. So if you wanted to go and change this back to burst, what you would actually do is go to that user dictionary and set the value for the key node shape, but it must be node shape like this. One word, all lowercase, right? So we can do that by going n dot, and then we would say set user data. Okay, and then we give it, now we've already given it self, because we're running it on the node, but then we need to give it the name and the value. So in other words, the key and the value, right? So the key is node shape, and the value is, let's go back to burst, okay? So when we run that, this now changes because we've changed our actual user data dictionary. Okay, and I can't actually remember off the top of my head now, but I have come across it where there was something else stored in this dictionary, so it is good. But remember, so this is user data, not cached user data, so this is not temporary. This is stored on the node, which means if I save, close, and reopen, this will stay like this. And if I copy this to another scene, the user data dictionary goes with it. Okay. But if, however, I had to set this using the cached user data dictionary, then it would be temporary, right? So we can store whatever we want in this dictionary, though. So we can now say n.set user data and go and give it our own thing. So we say, give it, maybe I want to store, I don't know, whatever, some other value. And the value I want to give it is maybe even a list of things, you know, and we're going to have to test now. I'm not sure whether you can give it anything. I think it does have to all be a string. So let's test it, okay? So let's say I want to give it a bunch of values, okay? Maybe some, I don't know, XYZ coordinates or something like that. Okay, let's try this. Okay, no, right. So it's not going to accept that, but I believe that if we give it a string here, it will take it as a string. And then, of course, we can just convert that back from a string to an actual list afterwards, okay, later on. So now if I say n.user data dict, it's going to return our dictionary, which has 2 keys. And so there's our stored value, right? And then obviously we can call just one specific value by saying n.user data, and then we give it the key name. So we just say node shape, and it will return burst. Okay. Now the functions for the cached user data are exactly the same. It just has the word cached in the front. So there is n.cached user data dict, which is empty, and we can do n.set cached user data and store something. Sorry, that'll have to be a string, and then we can do cached user data, and then we give it, and I spelt something wrong now, so I'm going to have to actually stick to my terrible spelling of it. And there it is. Okay, but just remember, if I save, close, reopen, it'll still have burst stored. It'll still have some other value with this list stored, but this value will be lost because it's cached user data. Okay. And then, just destroying or removing this data. Again, it's called destroy, which I find quite funny, is we can just go n dot, and then there is destroy user data or destroy cached user data, and that lets us destroy that. So we just give it the key as well. So destroy user data node shape will then revert back to the default node shape. Okay, so super cool, very useful, and in fact vital in some cases. You have to write data and store it on a node so that you can loop through and check that. So we need it. Right, and there's one last advanced thing that I wanted to show you, which is very cool. In fact, I'm going to create a new Python shell for this. Really nice when it comes to copying nodes or sharing things with other people. So there is a function on nodes called asCode, right? asCode, like this, right? Spelled like that. So it's a function on a node. And what it does, if I hit enter, look at this, it is a giant chunk of code. But essentially what this is it's created a code that would be used to recreate itself. Okay, but this is not just a bunch of random loose code. This is actually like correctly formatted code that is used to recreate the node. So in other words, if you just ran this function, like you could basically copy this giant string of text and put it into a text document, and that would form an actual script that, if you ran it, would create a node called test that would be green, that would be in this location, that would have a box inside of it with a display flag there and a render flag there, and it would literally recreate this. Okay. So we don't even have to format this code. So, well, this is very hard to read in this giant format. So what we're going to do is say, let's store it. So we're going to say, I don't know, let's call it my code equals, and then we do n dot as code. All right. So now we've stored that. If I print my code, properly print it, it actually prints it with where those, you know, because you'll see in here, there's a lot of bits where you can see it says, come on, where is it now? We'll see it says /n. So that's showing you that that's a new line, and then this has got a hash, which means that this is an actual comment. And then you'll see another /n, which means it goes to a new line, and that's the end of the comment. And there might be even somewhere it's got a /t for tab. Right? So it uses all of that formatting, so when we print it, it actually prints in this way, and you can see the actual lines of code that are used to create this node. Right? So let's find the beginning of it. Sorry, there's a lot of code to create a node, right? And I'm going to show you something else just now. But anyway, so we say as code. So it's got headings with comments, and then it says, and it's got these lines of code, and it's tabbed in properly, and then it creates a new node, and it's going to move things and set selectable, and it does all of these functions. So you can actually learn a lot by examining this code and what it's doing to recreate this. Now let's put this to the test. We stored the node, we stored the code as a string. So now if we delete the node, sure, n no longer exists, but my code does exist. And what if I now run this? Now there's a Python function to run an actual string as a script, okay? And that's called exec, okay? So you're going to execute this code. So we say my code, right? And it literally recreates the code, the node exactly as is, right? Now it hasn't included the internal contents, because I think we have to specify that as an argument, but because it's already a lot of code as it is. But this is just amazing that you can actually store it as properly usable Python code with proper formatting and everything. Okay, so let's just pull this up in here to see the arguments that you can say as code, right? So brief, for example, this brief argument lets it essentially be much briefer code, so it just makes a lot of assumptions for you. So now we can actually do that, like maybe we say here n dot as code, but then we say brief equals true, right? And now you'll see, okay, well that's hard to see, but there is actually a lot less code, right? I know it's still a lot, but it's actually a lot less. So we could even do this and say my code equals, and then print my code, and what you'll see is a much more manageable and shorter script to recreate this node, right? Then recursively apply the entire operator hierarchy. I think this might save the nodes inside. Should we try it? So let's say my code equals this dot as code, and then we set the argument is recurse equals true, right? And then we let's delete. Oh wait, there's nothing inside. Sorry, let's create something inside. Okay, so I create a grid, and then let me run that code again. So now it's restored that code. I'm going to delete this and say execute my code, recreates it with the grid inside. There we are. So this recurse is the one that will allow it to do that. Okay, and there's a whole bunch of other things. I'm not going to go into it. But basically this is a way of working backwards. Instead of typing the code to create a node, this is now taking a node as it is and showing how to rebuild the code. You can learn a lot from this. When you see here, it's setting the color, it's setting the expression language, setting the user data. Look, it's even stored that user data that we had previously. It's still stored on this node because we've recreated it from it. It's amazing. So very, very cool, just saying. All right. So that wraps it up. I know this was a long lesson, but there was so much to know about nodes, and this, by just playing around with nodes and functions, classes, modules, and stuff like that, this is what's going to get you to be comfortable with Python inside of Houdini. And then over time, what you do is you just learn more and more functions. You start going through and just going, oh, wait, what does that do? Ooh, I wonder what this does. And you just learn more and more. So basically, the sky's the limit. You can do anything in Houdini with Python. And this is the start of learning exactly how. Right. So I hope that was useful to you and very enlightening. And I look forward to seeing you in the next lesson, where we are going to be taking a similar approach, but looking at parameters and how we can manipulate those. Because basically second to nodes is parameters in terms of the amount of stuff we can do with it. Right. So thank you very much, and I'll see you in the next lesson.